Hello, Comparative Worldview students. Welcome to yet another YouTube online PowerPoint thingy. Um, this is a rather uh, longer lecture, and so I thought I'd save time so we could have more discussion. Your job is to listen and then scribble down questions if you have them and bring them up in class. Um, but also, this lecture deals with a lot of scientific detail and philosophical detail. And so I thought it would be helpful for you to be able to watch it on YouTube. If I said something that confused you, you could go back and replay it, and that's kind of awkward to do in a lecture, especially for some of you introverts who don't like asking questions and stuff like that. So here we go. Strap in. Hang on. This is going to take a little while. But Darwin, Charles Darwin, Chucky D, born in 1809, son of a locally famous writer and speaker, Charles himself was quieter, an underachiever. He preferred to collect beetles and go hunting. He went to the University of Edinburgh to study medicine, but he was simply too squeamish to practice the kind of medicine they were doing in the 19th century, so he dropped out. He transferred under his father's pressure to go to Cambridge University to study theology so he could become a pastor, a priest in the Anglican Church. And interestingly enough, it wasn't unusual for priests to also be naturalists, to study things and publish scientific results. But Charles was not into theology, and Cambridge at that time was not a very strong biblical Christian training, very influenced by German rationalism. That was then in fashion in the intellectual circles at the time, which tended to undermine the authority of the Bible. That is to say, his training was more deist than Christian in orientation. He soon drifted away into biology and geology, and in 1831, a biology professor recommended him to be the ship's naturalist aboard the HMS Beagle, bound for a 5-year voyage to survey the coast of South America. And if, for you nerds out there, if you know Star Trek, the original series, you will know that every episode started with a 5-year mission to explore new worlds, blah, blah, blah. Like, that was inspired by Darwin's journey. That's how the creator of Star Trek, whose name escapes me at the moment, thought about his show. So anyway, back to the Beagle, back to Charles Darwin. Charles Darwin had already read Charles Lyell's book on geology that argued that the Earth was far older than science supposed. And what Lyell was arguing from was like finding fossils of seashells near mountaintops, and then understanding how slowly mountains grow, and then just doing the math. And he was like, no, we're talking millions and millions of years. And so Charles Darwin is already thinking in terms of millions of years. His studies of the Galapagos Islands finches especially would become famous. That is, how the beaks of the finches are adapted to the different food sources on different islands. They're all kind of the same species, but they've grown into different species, or they all came from the same species, Darwin was thinking, and they all evolved into different species due to the different food sources, and the ones who had the certain beaks could survive with such and such, with seeds, the others with insects, and so forth. He returned to England and married his cousin, Emma Wedgwood, who is connected with, if you know anything about English China, Wedgwood is a thing. And Charles Darwin published some travel journals. In 1858, inspired by another naturalist's paper, a guy named A.R. Wallace, Darwin presented a paper on evolution at a scientific conference. And it was a race. Like, had Wallace gotten a book done first, we could be talking about Wallaceism instead of Darwinism, right? So Darwin published his paper, presented a paper on evolution at a scientific conference. It was not given a warm reception. But that paper grew into the 1859 book, The Origin of Species, and it is impossible to overestimate the effect of that book on Western intellectual history. By 1870, Darwin found himself to be the father of a movement called Darwinism, and one of the most famous men on the planet. In 1871, he published The Descent of Man, which was talking about human evolution from New World apes and things like that. And thereafter, he lived a quiet life studying botany. He died of a heart attack in 1882. He lies buried in Westminster Abbey. And at this point, if I were doing this live in class, we would pause for reading questions. We go through the reading questions. And there is a quote taken from a now deceased evolutionary biologist named Stephen Jay Gould, also very famous, from his book, The Meaning of Life, 1991. And I will read this quote for you, and I want you to think about this question and have an answer ready by the time we get to class, because I'll read this quote again in class when we do the Darwin questions. Here's the question I want you to think about. Is this quote, does it have primarily to do with scientific evidence, or is it a statement of worldview assumption? Is it a scientific statement or a worldview philosophy kind of statement? And I'm not going to answer here, but I want you guys to think about that. And here's the quote. The human species has inhabited this planet for only 250,000 years or so, roughly 0.0015% of the history of life, the last inch of the cosmic mile. The world fared perfectly well without us for all but the last moment of earthly time, and this fact makes our appearance look more like an accidental afterthought than the culmination of a prefigured plan. Moreover, the pathways that have led to our evolution are quirky, improbable, unrepeatable, and utterly unpredictable. Human evolution is not random. It makes sense and can be explained after the fact, but wind back life's tape to the dawn of time and let it play again, and you will never get humans a second time. We are here because one odd group of fishes had a peculiar fin anatomy that could transform into legs for terrestrial creatures, because the earth never froze entirely during an ice age, because a small and tenuous species arising in Africa 250,000 years ago has managed so far to survive by hook and by crook. We may yearn for a quote-unquote higher answer, but none exists. This explanation, though superficially troubling, if not terrifying, is ultimately liberating and exhilarating. We cannot read the meaning of life passively in the facts of nature. We must construct these answers ourselves. From our own wisdom and ethical sense, there is no other way. So, think about that and be ready to talk about it when we get to class. So, what is Darwinism? Let's get into Darwinistic theory 101. In 1859, Charles Darwin's Origin of Species delivered a devastating blow in favor of Enlightenment deism and then atheistic naturalism. Darwin himself seemed to be a deist. We'll talk about that when we go over the questions. Darwin's theory of evolution has done more than almost anything else in the last 2 centuries to make atheistic naturalism the accepted worldview for the majority of intellectuals in the West. The problem Darwin was attempting to solve was, how in the world can I explain the appearance of design, the great complexity and diversity of biological life, without having to refer to the direct intervention of a great divine designer? Darwin was aiming at the deist and theist arguments made famous by 18th century Anglican theologian and philosopher William Paley, here pictured. And Paley's argument went like this. Suppose you're walking on a beach and your foot hits something hard and you look down and it's a rock. Okay, no big deal. But if your foot hits something hard and it's a watch, and you bend down to examine it and you open it up and you see all of these little pieces fitting together to make a complex pattern of a whole, well, then you've got something different. It's not just a rock. It didn't just get here by chance. There must, you reason, be a watchmaker who has a purpose in putting this machine together in just this way. And Darwin wanted to find a way of explaining the watch in all its complexity, not denying the complexity, but he wanted to explain the watch without having to refer directly to a watchmaker. That is, creation without a willful divine purpose or design. And the solution he came up with was natural selection plus chance, spontaneous genetic mutation, plus a whole lot of time. So what is natural selection, or what sometimes gets referred to the struggle for survival or the struggle for life? Natural selection is this. In an environment where there are limited resources, so not enough food for everyone, not enough for everybody to survive, only those plants or animals best adapted to that environment will survive, can survive. So for plants that compete for sunlight, only the tallest will survive, or the ones who adapt their chemistry to make do with less sunlight. Shade plants, we call them today. Or for wolves, the fastest and best hunters will survive. For elk, those who run fastest to escape the wolves will survive. Giraffes developed necks long ago to survive. The ones who had longer necks and could reach the leaves higher up on the tree during dry seasons when all of the ground vegetation was dead, those ones didn't starve, they survived, and they got, therefore, generation by generation, those genes got passed on and they got longer necks. The best survived to pass on their traits to the next generation. Darwin further hypothesized that the complexity we see now is due to that process of adaptation to various environments through natural selection over millions and millions of years. All life had started with a single organism, he thought, and through natural selection and random mutation, that is chance changes in the organism, they're gradually, and gradually is an important word here, gradually developed the many different species that we have today, each with a different place, each with a different environmental niche, until we have ended up with the amazing complex diversity that we see today. The illusion of design is merely natural selection honing and perfecting random mutations. Complexity and the appearance of design is all accounted for without having to posit a creator with a purpose who intervenes directly in nature. That's kind of deism, right? Darwin's theory has been accepted by the mainstream scientific community as the reigning orthodoxy for the past 100 years or so. However, a couple of decades ago, some scientists and philosophers of science from a variety of fields, from a variety of scientific fields, began to voice concerns about problems that come up with Darwin's theory. This has to do with, this has led to a very heated debate, especially in the United States and to a lesser extent in Europe. So here are some of the problems that these scientists and philosophers have raised. Life from non-life. This is also called the problem of abiotic genesis. Like, how do you get life from non-living chemicals that were supposed to be around at the beginning of life around 3.5 billion years ago? Now, you will hear people say, Oh, well, scientists have created life in the laboratory. This is not exactly true. What they're referring to is the famous Stanley Miller experiment in 1953. Stanley Miller, a biochemist, recreated what he thought the atmosphere on Earth would have been like 4 billion years ago, which would have been lots of hydrogen-rich gases like methane, ammonia, water vapor. Um, and then he shot electricity through that mixture, and it created a red goo containing amino acids, which are the basic chemical building blocks for life, but not life. And even it's not even that. Amino acids are the basic building blocks for proteins that get made into proteins of different shapes. And those proteins are the building blocks of life. So we're still two vital steps removed from quote unquote creating life in the laboratory. Since then, however, doubt has been cast upon the Stanley Miller experiment because scientists are fairly sure that the atmosphere of the Earth would have been very different. Most of the hydrogen would have vented off and escaped into space. The atmosphere, therefore, would have probably been mostly nitrogen gas mixed with carbon dioxide and water vapor. And you do the same experiment with that mixture, and you get very different compounds. You get formaldehyde, carbon H2O, and cyanide, carbon nitrate, with a minus. I think that's having to do with electronic charge. You do not get chemicals that could support life. Even more troubling for the evolutionary understanding of the beginning of life is that more and more life is being understood as an information-dependent system. Life is not simply chemicals. It is rather primarily information transmitted through DNA, which acts like a chemical language, issuing commands to RNA for making and arranging different proteins, folding amino acids into proteins in different shapes. And the proteins that RNA constructs act as machines within cells, doing various jobs like repairing cell walls, transporting energy for the feeding of the cell, and so forth. Without that information directing the making of proteins, life cannot exist. The problem for an evolutionary understanding of the beginning of life, then, is where did the information come from that directed the formation of these first proteins? You can't get that sort of information from a combination of chemicals. In fact, the guy who wrote, the evolutionary biologist who wrote the standard textbook on how life arose from organic chemicals, a textbook called Chemical Predestination, a biophysicist named Dean Kenyon from San Francisco State University later disavowed his findings because he realized after further research that chemical compounds cannot give you the information patterns necessary for life to begin. In a sense, you need language before you get life. So where did that first information come from? This is precisely the reason why Francis Crick, who with Watson won the Nobel Prize for discovering the double helix structure of DNA, that's why he believed that life on Earth must have been brought here from another planet. And famous atheist biologist and atheist evangelist Richard Dawkins agrees. Aliens might have started life on Earth. Whatever it was, Dawkins is sure it wasn't God, which might point to a fact that his problems with God are not merely rational. But that answer merely pushes it back. How did that alien life get started from non-living chemicals? Where did that information come from? And for those of you who are internet savvy, sorry for the dank meme. They get danker. And it was this that convinced the famous atheist philosopher Anthony Flew. Back when I was in university, Anthony Flew was the preeminent guy who was writing atheist arguments against belief in God and stuff like that. He was famous. But I think he died several years ago. But before he died, he was like, nah, I believe that there has to be a God. I don't believe in the God that the Christian right is pushing. I don't believe in the Muslim God because there are too many problems with those guys. But there has to be a God for us to get life from non-life. Life couldn't simply have started from non-living chemicals. The second problem is the fossil record. Darwin predicted a gradual change in species becoming more and more complex over time, over a span of millions and millions and millions of years, even billions of years actually. And it should look like this, a branching tree. You will see this still in evolutionary textbooks. But actually the actual fossil record doesn't look like a gracefully branching tree. What the fossil record actually shows is a few species for like a couple billion years, and then an explosion of new species. This is known as the Cambrian explosion. And that Cambrian explosion brings a whole bunch of new species into the mix in a very relatively short time, no more than 5 to 10 million years, probably less. The more fossils they find, the window used to be 40 million years, but the more fossils archaeologists discover and research and date, the narrow that window becomes. It is now estimated to be no more than 5 million years old. Now, 5 million years sounds like a long time, but picture the history of life, all of that time starting at your shoulder. The Cambrian explosion occupies the space of a knuckle. That's how long it is with regard to the history of life. Within that short time, 20 of the 27 phyla that we now find in fossils appear, dozens of different body types, many with no known predecessors. That's those dotted lines in this graph I'm showing you. At least no known predecessors that we found in the fossil record. They just kind of appear. Boom. It is simply a massive information of new genetic information. When I was researching this, I came across one biologist's website that said it was like somebody in a spaceship came by and sprinkled magical pixie grow dust on Earth, and everything just went bonkers, went crazy. Now, evolutionary biologist and atheist naturalist worldview apologist Richard Dawkins said in his book The Blind Watchmaker, which is his take on the watchmaker argument from Paley, and said the watchmaker is blind, it's all chance. But he says in that book, quote, "It's as though they were just planted there without any evolutionary history." That book is from 1996. Perhaps, he speculated, these Precambrian animals had soft bodies and so couldn't fossilize, though we have plenty of other soft-bodied organisms that have been fossilized. But the consensus is clear: very little evolutionary activity, and then a rush within a very short period of time. In all, there were up to 40 completely new body designs that emerged in the Cambrian explosion, each of which needed a lot of genetic information to develop. Where did all of that information come from? There is simply no way for evolutionary biologists to explain this explosion, though they have tried thus far with not huge success. This is why neo-Darwinists have come up with theories of saltational evolution, that is, evolution that happens by these sudden jumps, or punctuated equilibrium, that is, when one thing develops, everything else develops really fast to kind of equalize things out, and then it stabilizes for long periods. There's another theory called snowball Earth. That is, there was a sudden freeze on Earth that led to a warming and an infusion of oxygen, which led to an explosion of species. But oxygen is not information. Like, even with these modifications, there is simply too much development, too much new information added into the biological systems too quickly. A random series of gradual evolutionary changes does not seem to be able to account for it all. And that's a problem for Darwinian theory. The last challenge I'll mention is one that was posed by a group called the Intelligent Design Movement. And this is a group of scientists who have found significant problems with Darwinian evolution, and they mention these other problems. But one of the leaders of the group is a microbiologist from the University of Lehigh, Pennsylvania, not so far from where I grew up. And he wrote a book back in 1996 called Darwin's Black Box. And you read a very short summary of one of the chapters in that book. In it, Behe said that the cell in Darwin's day was a black box. That is, because they just didn't know what was in the cell because the microscopes weren't very powerful back then. Back then, the scientists thought that cells were just solid, just a gray blob of gray goo, and who knows why they did whatever they did. But in the 1960s and 70s, new powerful microscopes called electron microscopes started changing that. They were able to see inside cells. And what they saw was complex machines, hundreds of tiny, intricate machines made of proteins, which were made from amino acids. These machines help the cells to move, to repair themselves, to feed themselves, to clot blood, and so forth. And all of these machines are very specific, are finely tuned. That is, they were constructed of many complex parts that had to fit together exactly if they were going to function properly. And Behe uses the example of the illustration of a mousetrap. If you make the platform too thin, then the mousetrap collapses because of the tension of the spring. If you make the spring too loose, then it doesn't snap. If you make the trigger, if you change any of these parts too much, the whole mousetrap just doesn't work. You don't catch mice. You don't have anything worth anything. In other words, and that is what Behe called irreducible complexity. You cannot modify any of the parts too much without destroying the system, and that would cause it to lose functionality. The example he uses in the book is the cellular machine of the flagellum motor. Flagellum is the whip-like tail at the end of a protozoa, a microscopic animal that uses it to get around. They just kind of go and they go off. And you just look at it, and each of those different things, those lumps on this illustration, are individual proteins that have been bent into a specific shape to do a specific thing. And it looks for all the world to be a marvel of engineering. It can spin up to 20,000 revolutions per minute and can change direction in a quarter of a turn. If you gradually alter the parts of that machine, that outboard motor, the motor that makes it go, the machine doesn't work, and therefore the cell doesn't survive. The adaptation of any of those parts gives no competitive advantage in the struggle for life. In fact, a non-working flagellum becomes a really big disadvantage for the organism. It now has an anchor rather than a propeller, and therefore it cannot run away when predatory single-celled animals come to feast on it. And there are predatory single-celled animals. So what does this mean for the theory of evolution? Darwin, in The Origin of Species, had said, If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down, but I can find no such case. What irreducible complexity means is that there is no way to get gradually, part by part, adaptation by adaptation, from one set of cellular machines, biological machines, cellular set A, that has one set of biological machines, to species B with another set of cellular machines, without destroying the organism that depends on those machines. They don't survive. There's no way to explain, according to Behe, there's no way to explain how one species can evolve conceivably into another species and survive at the microbiological level. So intelligent design proposes that an intelligent designer would have to intervene. These cannot simply be random changes. They must be guided by an intelligent designer. Those committed to Darwin's theory, such as Kenneth Miller, also in your reading, counter that many of these machines contain smaller, simpler machines, such as a microsyringe called a type 3 secretory system or secretory apparatus that could be used in cells and later become more complex machines like the flagella. So what this little thing does is it pokes other cells and it either slurps stuff out of them or injects a toxin into them. Pretty cool. I mean, if you like that sort of thing. But that answer to Behe's challenge only raises more problems. There are some 30 different proteins found in the flagellum not found in the microsyringe. Where did they come from? How did they get there? And can we see any kind of step-by-step scenario whereby this very much simpler machine can be transformed into the complex machine and have an organism that is able to survive all the steps of the intermediary changes? That's the challenge. Furthermore, many microbiologists now believe that the type 3 secretory system, this little microsyringe, developed much later than the bacterial flagellum due to DNA evidence, that is the distribution of the flagellum DNA versus the little microneedle DNA. That points in that direction. That means that the simpler machine evolved out of the more complicated machine by stripping parts away. But that means that the development of this complex bacterial flagellum machine is still unexplained. So that is Behe's microbiological challenge to evolutionary theory. You must be able to explain step by step how one microbiological machine evolved into another without the system completely breaking down and therefore not allowing the larger mammal to survive. This challenge seems to or larger animal to survive. This challenge seems to pose a huge obstacle to evolutionary theory, despite the confident assertions by Miller. However, and this has been influential in my own thinking, recent work in genetics, and by recent, I mean like in the past 35, 40 years and beyond, shows that evolution doesn't have to build molecular machines step by step. Genes can cause cells to jump steps, skip steps altogether when a genetic code becomes mismatched in an egg cell. A changed genetic code there, which can include transposed genes in which the code becomes upside down, or duplicated genes, these can produce a completely new set of cellular micro machines without the intermediate steps. A group of genes known as homeotic genes, which are essentially control panel genes, were discovered by geneticists Ed Lewis, Karistien, Nussel Volhard, and Eric Weishaus for which they won the Nobel Prize in Biology in 1995. These homeotic genes can even control the placement of whole organs. And when those genes mutate, you get really freaky results. And these genes seem to offer a workaround of Behe's microbiological challenge. On this slide, you see two fruit fly heads. The one on the left is a normal fruit fly, and coming out of its head are little antennae. The one on the right, scientists have messed with the homeotic genes in the fruit fly and changed something which, instead of antennae coming out, has two fully functional legs coming out of its face. So, which is very weird. And when you see like human ears growing out of the backs of mice and things like that, they're messing with the homeotic genes is what they're doing. So it begins to look as if perhaps Behe's microbiological challenge to evolution as a scientific theory isn't nearly as insurmountable as it first appeared, since you don't need to have a step-by-step evolution from one set of machines to another. Genetic transfers, duplications, transpositions, especially of the large-scale homeotic type, give evolutionary change a back door to exploit. New machines appear whole, with modifications, and sometimes those are compatible with life and sometimes not. They might conceivably give a competitive advantage, although fruit flies with legs growing out of their heads, probably not. Many of these genetic discoveries occurred after Behe wrote Darwin's Black Box, but he responded to it in his next book, The Edge of Evolution, which I think was like 2006. These homeotic genes or control genes are themselves amazingly complex. And here's a schematic of one. It looks sort of like the schematic of a computer chip. It is that complexity that allows them to make such radical changes in the organism. And Behe asks, okay, great, you've got homeotic genes. How is it possible for that kind of complexity, that kind of complex gene to simply evolve? Please explain that to me step by step. So Behe followed up Darwin's Black Box with his second book published in 2007. Sorry, not 2006, 2007, The Edge of Evolution, The Search for the Limits of Darwinism. And in it, he answered his critics about homeotic genes and so forth, but he also refined his argument in a very interesting way, and he tried to forge a middle path in this debate over evolution versus creationism, which is really a hard feat to pull off in a debate where the tone has been set by Richard Dawkins, who said in a New York Times book review of The Edge of Evolution, it is absolutely safe to say that if you meet someone who claims not to believe in evolution, that person is ignorant, stupid, or insane, or wicked, but I'd rather not consider that. Sure you would, Richard. You've been calling people like that evil for a long, long time. He is not the most generous of people. In the book, Behe asserts that Darwinian evolution rests on two basic concepts. Number one, common descent. That is, all biological life descended from simpler forms. And number two, the ability of random mutation plus natural selection to build complex new structures. So he affirms the first, common descent, and he says that's all but undeniable. There's no way you can argue with the scientific evidence. But there are real problems with the second, that is, random mutation plus natural selection can build new structures. So about the first, the common descent, we all descended from earlier forms of life. He said that the genetic evidence points almost undeniably to common descent. He discusses the fact that our genes are remarkably similar to chimpanzee genes. And by when I mean remarkably similar, there are places where our genes are broken in the same way, in the same place. In normal mammal hemoglobin, There's a gene that helps animals create their own vitamin C. That gene is broken in both chimps and humans, making it look like we had a common ancestor for both chimps and humans. Further, in both chimpanzee and human hemoglobin, blood DNA, there is a broken non-coding genes. There are genes that don't actually do anything except provide a buffer for the coding genes. These are non-coding genes, and so they wouldn't have been, we wouldn't have noticed it had we not mapped out the whole human genome and the whole chimpanzee genome. And sometimes when genes make copies of themselves, those copies are defective and they don't code for anything. Genes can be broken in a variety of ways, but this particular gene is broken in exactly the same way, in exactly the same place on the genome of the hemoglobin DNA. That, he says, is a smoking gun. And for those of you who don't know what I mean by smoking gun, in a murder mystery, if the detective walks in and there's a guy holding a gun and a person who's been shot lying dead in the corner and the gun is smoking, then you can safely assume that he just shot the person, right? It's certain. So this is smoking gun evidence for the fact that human beings and chimpanzees share a common ancestor. That is undeniable. So he says, it looks like Darwin was right. Different forms of life share a common bond. They share a common ancestry. But, he says, common ancestry is unimportant if you cannot explain how it is that we share a common ancestry. And that's when Behe turns to the second big idea, the ability of random genetic mutation plus natural selection to build complex new biological structures. Behe says, quote, after looking at the evidence, I conclude that there is no way a random process plus natural selection can explain evolution. So let me explain this a bit. The orthodox view of Darwinists uses the metaphor of a Cold War arms race. During when I was growing up, the Russians and the Americans each saw what the enemy was doing with their weapons technology, and they would like, oh, Russia has made a better bomb here, we better make a better bomb there, so that things would be equal, and each would counter the other's move by making a better technology of their own. Life, according to Orthodox Darwinism, does the same thing. In any given environment, whenever one species advances, then it sparks an arms race in the other competing species to change and adapt to keep up, or they face extinction. Through random mutation and natural selection, each of them builds complex new biological technologies that will give them an advantage, forcing other species to construct their own new randomly mutated biological technologies. Behe says that's a bad metaphor because random mutation doesn't really work like that. A better metaphor in the war of the species versus species is not a sophisticated arms race, but trench warfare from like World War I. Your enemy is coming and you shoot until you're out of ammunition, and then you just throw the gun at them and you rip the sink out of the walls and you launch that at the incoming enemy. It's brutal, it's ugly, it's clumsy, and it does not produce new genetic biological technologies. So to prove his point, he looked at examples where he had lots of specimens to observe and lots of generations, so that you'd have lots of chances for random mutations to occur to see if they could in fact build new complex biological structures. He looked especially at malaria studies because malaria reproduce so fast. Once a person has been infected, a single malaria cell produces 20 copies of itself in a day, and those produce 20 copies of themselves, and so on and so on. And in a week, in a few days, you can have 1 trillion malaria cells in the victim's bloodstream. So each of those replications, each of those generations of malaria cells give plenty of chances to watch for random genetic mutation at work in both the bacteria and the body's response to the bacteria. So he looked at about 50 years of malaria studies, and what he found is that random mutation plus natural selection is really good at breaking things, like making defective copies of genes, and that sometimes, rarely, but sometimes really does confer an advantage for survival. For example, sickle cell anemia is caused by a broken gene in which the blood cells are made in the wrong shape. They're supposed to be this nice disc-less frisbee shape, which allows for the carrying of oxygen and stuff like that. In sickle cell patients, the blood cell gets folded over and looks like a banana or a burrito, and it's just not as effective for carrying oxygen. And therefore, sickle cell anemia proves fatal in most cases by the age of 30, but it also protects the person from malaria. They are immune from malaria because the malaria cells don't have the right surface to latch onto. And so this person just doesn't get malaria. By age 30, many of these people who die have had a chance to have children, and so they pass on that mutation to their children, which may activate or it may not, depending on you guys know the laws of genetics and stuff like that. Sometimes it's a recessive gene, sometimes it's dominant gene, whatever. But what doesn't happen, Behe says, is that you get a new structure that is built that wards off malaria. Rather, what you get is an old structure that gets broken, and that helps for a time, like 30 years. On the malaria parasite side, a broken gene sometimes changes an organism in a way that enables it to survive anti-malarial drugs. But often for powerful drugs, such as chloroquine, you need 2 or 3 of exactly the right types of broken genes or mutations. And every time you add another mutation, the chance for getting it the right one goes down exponentially. It's like winning the lottery 10 times in a row. But because these things replicate so fast, within 40 years, chloroquine has become completely ineffective. The virus mutated, which broke its stomach, the gut of the malarial cell, in a way that made chloroquine ineffective, which is a shame because it was, 40 years ago, or however many years ago, it was a very cheap and very effective way of getting rid of malaria, of poisoning malaria and making it die. But malaria mutated in a way that made it immune from getting poisoned from chloroquine. However, sickle cell anemia has been around for thousands of years, and malaria has yet to evolve a way of dealing around that. Anyway, so that's his 2007 book. Behe followed up with a third book called Darwin Devolves. And here he builds on his earlier argument, presenting evidence that far from building new structures, evolution happens by damaging the genome rather than making it more functional. And that book has also sparked heated debate. Most scientists dismiss his arguments. If you're interested, Behe posted links to the criticisms and his responses to the criticisms on his book website, darwindevolves.com. All right, now let's talk about the current debate over Darwinism. The majority of biologists and other scientists have been reluctant to take these criticisms seriously, however, because they believe there is still good evidence for Darwinism, such as, number one, the progression of species in the fossil record from simpler organisms to more complex organisms, that looks like evolution in action. But note that Behe and others don't say that there is no progression towards more complexity, only that it's impossible to explain that increased complexity on an entirely naturalistic basis, random genetic mutations plus time. Second, evolutionists point out that chimps share 98.8 of their coding genes with humans, including common genes, common mutations of exactly the same gene at exactly the same place in exactly the same way, making the chance of a common ancestor very, 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 very likely. Behe doesn't dispute this, but some other critics of Darwin say that the differences between animal and human are still very profound, regardless of the genetic overlap. And thirdly, the process of certain vestigial organs that are seemingly useless, such as the appendix or the tonsils, or non-coding. Well, back when I was in university, they talked about junk DNA. That is, it's not called junk DNA anymore. It's called non-coding DNA. It was supposed to be just leftover garbage from evolution that, but it's not needed anymore. Many of the useless parts of our body turn out to have a use after all. When I was in 5th grade, I kept getting sore throats and colds and stuff like that, and therefore they cut out, the doctors cut out my tonsils. It's one of the few surgeries I've ever had in my life because they were like, this is just, it doesn't really do anything except become an attraction for all these diseases to kind of nestle in there. And so they cut them out. Later research found out that they're actually important for the immune system. Surprise, surprise. But they didn't know that when they were just considered vestigial. In other words, the more that we learn about human DNA, the less junk DNA we find. Like the things that we considered junk back in the 1970s are now considered, oh, that's important. And even the non-coding parts of the genome serve a purpose. They are buffers for the coding parts of the genome, so that the chances of a coding gene getting hit with a mutation that could kill a baby in utero by having, trisomy 13 or whatever, that lessens because you have these buffers of protection. So basically, the more we find out about the human body, the less useless parts we find. I don't know of recent work on the appendix or the tailbone, but it could be that later research finds out, oh, this actually does something for digestion. And many scientists believe that, even with these problems, many scientists still believe that Darwinism offers the best explanation. At least it points to some natural mechanism, and they don't want Darwinism to be discarded until there is another explanation that appeals only to natural causes. And so far, no one's been able to find one, though there's been interesting discussion about what's called the third way of evolution, or evolution 2.0. And in your Neo folder, there are some links to debate sites about that. Basically, it's the idea that somehow at the molecular level, there is a native intelligence in cells that guide them to building complex biological machinery. It has created a lot of debate. It's very heterodox view of Darwinian evolution. But it is yet another debate that's going on currently. However, it is crucial to remember the difference between Darwinian evolution as a scientific theory, that is, it's a theory that just fits the data better as far as we know them, which I think Darwinism does, though as we've seen it has problems, and Darwinism as a worldview assumption. The former is a theory chosen by science because it seems to fit the data better. The latter believes that it proves atheistic naturalism because Darwinism, that the universe runs on random chance and natural selection, and that is that's not science. An alternate reading of the data could easily conclude that God used and still uses evolution as his mechanism of creation. This is precisely the position of theistic evolutionists. That is what we perceive as chance really purely chance, or is it a guided process that merely appears to us to be chance? And that is an answer that science cannot give you. Science cannot provide you an answer to that question. Science cannot prove one worldview or another. Rather, atheistic naturalists kind of smuggle in worldview assumptions into their practice of science, as Richard Dawkins and, spoiler alert, Stephen Jay Gould do. But at that point, they're not doing science anymore. They're starting to do philosophy. And as we shall see, there are profound philosophical problems with the naturalist worldview. So not only does Darwinism have problems as a scientific theory, but it also had problematic effects on the popular imagination in the 19th and early 20th centuries that led to some tragic social consequences. Now, I want to be clear, this does not disprove Darwinism. However, it does show where some of those ideas lead when they are taken as proof of a worldview. These ideas, which at the time seemed reasonable because of the evolutionary understanding of progress, are now soundly rejected by most. But they were believed in because of the impact of Darwinism on the popular imagination. For example, once upon a time, it was believed that some races were more evolved than others. Darwin's theory talked about the increasing complexity of species in terms of progress, although, strictly speaking, in Darwinism, there is no progress, there's only better adapted to a specific environmental niche, right? What I'm trying to say is there's no better unless you have some transcendent criterion according to which you can judge whether you're getting better or worse. And Darwinism or atheistic naturalism denies that. But still, the idea was species, human races are becoming more and more complex and advanced as they get more white. During the popular 19th century mind, during the Industrial Revolution, which was very much enamored with this idea of progress, right? Ideology of progress, remember that? Darwin's ideas, and there's evidence that Darwin believed this as well. Darwin's ideas seemed to give legitimacy to the idea of that one race was more advanced or more evolved than others. And that made it easier to exploit black people or Asians, for instance, who were thought to be closer to apes, less evolved. This cartoon this illustration on the bottom of the slide is from a magazine published in New York called Harper's Magazine, and I think it was in 1896, 1894. I can't remember out, but the text is really hard to read. And I'm sorry, I searched, but I could not find a better resolution for this old photograph. There is a copy of something sitting in a library somewhere, but I haven't found it. But let me read it to you because I've spent a lot of time looking at it. It says the Iberians, that is people from Spain, the Iberian Peninsula. Who knew the Iberians and the Irish were actually the same thing? The Iberians are believed to have originally been an African race. Oh, Spanish people were Africans who thousands of years ago spread themselves throughout Spain over Western Europe. Their remains are found in the barrows or burying places in sundry places in these countries. Their skulls are of the low prognathous type, that is closer to ape skulls. They came to Ireland and mixed with the natives of the south and west, who themselves are supposed to have been of the low type and descendants of savages of the Stone Age, who, in consequence of isolation from the rest of the world, had never been outcompeted in the healthy struggle of life, and thus made way, according to the laws of nature, for superior races. And here the argument is, look at the head shape. Look at this nice head shape. This head shape here is nice and high. Here it's more like Cro-Magnon. It's lower. Got it? Anyway, so that in turn, that kind of racist science or racist pseudoscience that grew up out of this belief in Darwinian evolution that is applied to human races lent scientific legitimacy to the types of racial purity espoused by the Nazis in Germany during World War II, later by skinheads and white nationalists, and other fascist and racist groups today. The second impact was laissez-faire capitalism, or social Darwinism, as it was called. In the 19th and early 20th centuries, Darwin's principle of natural selection was applied to sociology and economics. If people were poor, that showed that they were unfit in the struggle of existence within society. They were not adapting to their environment well enough. Social welfare, helping them out, would actually help the unfit to survive and thus weaken the whole social system, and particularly weaken our species. Only the fittest, the most successful, should survive. Overcrowding, losing children to malnutrition and disease was hardly uncommon for working class immigrant Americans and the working classes in Europe in the 19th century. So combine that belief in social Darwinism with the Darwinist-informed racial stereotyping of the day, and many believed that Central and Eastern European Jews, Russian Jews, Italians, Irish people, Chinese who came flooding into America in the late 19th century and became stuck in poverty because they were given low-wage jobs for which they were paid almost nothing. They were just less valuable as people than the more established, richer Anglo-Americans and Scandinavians who had arrived 100 years before. It was a convenient way of dealing with overwhelming poverty. You didn't have to do anything for those people. They were simply less fit for survival and competition. In fact, if they lost one or two kids to malnutrition or preventable childhood diseases, wasn't that good for all of us? It made us stronger as a species, weeding out the weakest in the struggle for survival. And these are kind of assumptions that linger behind anti-immigrant attitudes today. Now, I want to be clear again that I do not know of any mainstream thinker who still holds these views based on Darwinism, except for like fringe, well, it's hard to call white nationalists fringe when they're kind of making great gains in American society at the moment. But anyway, there aren't really any mainstream thinkers that still hold these views based on Darwinism, but it does raise an interesting question. If racism and laissez-faire capitalism or social Darwinism, if these were not legitimate inferences and consequences to draw from Darwinism, why not? If Darwin doesn't lead there ethically, because racism and leaving the poor to starve lead to a violation of basic human rights, if Darwinism doesn't lead to social Darwinism and racism, where does it lead? Can there even be universal human rights based on Darwinistic assumptions? Listen, Darwin described the way the world is. Animals compete. Some species hunt other species to extinction. And that's not wrong. It's just the way the world is. But it does not speak to the way the world ought to be, which is what our morality and ethics is about. But if that's the way of the world, if that's just how the world is, it's hard to understand how you can see humans as absolutely valuable. And indeed, some naturalists don't see humans as absolutely valuable. And in this regard, I think Glenn Tinder and not Richard Dawkins is right on the money. All right, that's the lecture. About an hour and 7 minutes. This is going to be part of your homework when we get to atheistic naturalism. I would ask you to write down questions, bring them to class. We can discuss them. When I ask if there's any questions about the reading, just kind of fire off those. Okay? Thank you for your attention, and I will see you guys in class.